Alright, boys and girls, today we are on section 7.4 and we're going to be multiplying fractions with models. Now when we do it, it's going to kind of look like an array. It might look like something you've done on a computer program before, like ST Math or 10 marks. So it shouldn't be that complicated. It looks different, but it's really, the concept behind it is still the same. We're still doing numerator times numerator, denominator times denominator, but we're using a picture and some coloring to help us understand where these numbers are coming from. So here's my first problem. 1/4 times 2/3. So with this problem, what I'd like you to do is to draw that rectangle. And just like a third grade array, I have 1/4 on one side and 2/3 on the other. So for my 1/4 on the side, you can see that I cut it into 4 pieces going across. 1, 2, 3, and 4. So then with that, I'm going to shade in one whole row of that. And then going up and down, you can see that I have cut it into thirds, because that's what my denominator is thirds. And then I'm going to shade in 2 entire columns. So once you do that, you can count how many blocks have been shaded in both directions. 1, 2 blocks that have been shaded in both directions. And then I look and I say, well, how many blocks are there total in my array? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2/12 of my array is shaded in with both colors, both pink and purple. And then I can simplify that by dividing both sides by 2. So my final answer is 1/6. And I can check that using standard algorithm to make sure that my model matches my standard algorithm. 1 times 2 is 2. 4 times 3 is 12. Same as I had gotten in my model. I know this is a different way of looking at 1/3. I'm going to do 1/3 here. So I'm going to go across this way and cut my rectangle into thirds. And I'm going to color in one of them. Now going in the perpendicular, the opposite direction, I'm going to cut it into fourths. I'm going to represent my 2/4. So I'm going to cut it into fourths. 2, 3, 4. And I'm going to shade in 2 of those columns because that's what my numerator is. So the total number of pieces that I have here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is my denominator. Now I look at how many pieces are colored in with both my red and my purple. And I only see 2. And you can check yourself using standard algorithm. Now if I divide both sides by 2 to get it in simplest form, then my final answer is 1/6. Let's give this one a try. 3/5 times 1/3. I'm going to go 3/5 right here. Change it up a little. So I'm going to make sure that I have 5 columns. 5 columns. 2, 3, 4, 5. And in the opposite direction, I'm going to represent my 1/3. So I'm going to make sure I have 3 rows. 2, 3. Now what I forgot to do, that's my fault, is I forgot to shade in my 3 columns out of my 5. So I'm going to go back and go 1, 2, 3. And then I'm going to shade in one red row. I count my total number of pieces, which is my denominator, and I have 15. And then my number of pieces that are both purple and red. 1, 2, 3 is 3. And then I can simplify that by dividing both numerator and denominator by 3 and getting 1/5 as my total final answer. Now I'd like you to try this last one on your own, but I'm going to help you set it up. I'd like your 2/3 to be here, and I'd like to see your 2/5 here. So you're going to cut 3 and then 5. Go ahead and try that now and see if you get my answer. So there's my final answer. I made 3 rows and colored in 2 of them, and then I made 5 columns and I colored in 2 of them as well, giving me a total of 4 pieces that are colored both purple and red, out of a total of 15 pieces. If I count all the pieces, that gives me 15. Please let me know if you have any questions. I know this is a little bit different way of looking at it, but please try and understand and go back and re-watch your video and make sure that you're understanding where these numbers are coming from. And if you don't, then ask questions tomorrow.